Good afternoon, everyone. It's a great honor for me to be here today, share some recent works, Ballot permutations and words. This work is joined with Professor Zhicong Lin, David Guoliang Wang, and Tongyuan Zhao. Here's my work unit college and my emails. This talk has 3 sections. The first is spurious conjectures and refined conjecture. The second is a decomposition of Ballot permutations. The last is pattern avoidance on Ballot permutations and words. Let's begin the first section, spurious conjecture and refined conjecture. Let Sn be the symmetry group of all permutations over a natural number from 1 to n. A composition I is in a permutation pi is a descent if pi I is greater than pi I plus 1. I is an ascent if pi I is less than pi I plus 1. The number of the descent is denoted by das pi, and the number of ascent is denoted by s pi. The Ballot permutation is a permutation which no prefix have more descents than ascents. Prefix means from pi 1 to pi I. I is from 1 to n. No prefix has more descent than ascent is every prefix of pi. The ascent is no less than the descents. An odd-ordered permutation is a permutation which are product of cycles with odd lengths, such as 1, 2, 3, 4. Is an odd-ordered permutation. For each cycle is odd length, length 1, length 3. We denoted the Ballot permutations of length n by Bn, and odd-ordered permutations of length n by On respectively. Here are examples. For n equals to 4, B4 has 9 elements. For 1, 4, 3, 2, its prefix has 1 ascent, 1 descent, and 1 ascent. The ascent is always no less than the descents. And O4 also have 9 elements. Each cycle has odd elements. ID means 1, 2, 3, 4, 4 cycles. In 2010, Bernardi, Damplantier, and Nadius proved Ballot permutations and odd-ordered permutations are equinumerous. Spiro gave a refinement for very introducing a new statics, accidence pi. Accidence pi is the sum of each cycle C of pi, the minimum of the cyclic descent, and the cyclic ascent. For example, here is a cycle C. The cyclic descent is the number of the descent in this cycle for this 4, 2, and 8, 5, and 6, 4 is a cyclic. The 4 is also after the 6. So the cyclic descent of this cycle is 3. And the cyclic ascent of this cycle is 2, 8, 5, 6. So the cyclic ascent of the cycle is 2. And accidence pi is the sum of each cycle C of pi, the minimum of cyclic descent and cyclic ascent. Spurious conjecture is the number of Ballot permutations of Sn with just d descents equals the number of odd-ordered permutations pi plus n, and such that the accidence pi is d. In 2022, Professor David Guoliang Wang and Tongyuan Zhao confirmed this conjecture by calculating their bivariate generation functions in the term of the Eulerian numbers, denoted as A and D, the number of permutations over from 1 to n with d descents. Here's their main result. Professor David Guoliang Wang and his postgraduate Jerry Zhang refined spurious conjectures by considering the number of the largest letter in a permutation. In Bn, the largest number is n. We call a word u as a factor of a word if there exist words x and y such that w is x, u, y. X is u's left neighbor and y is u's right neighbor. And u as a cyclic factor of a permutation pi if x, u, y is a set of pi. Wang and Zhang conjectured for all nd and j from 2 to n-1. The BNDIJ is the number of Ballot permutations of length n with d descents which have a and g as a factor. And PNDIJ is the number of ordered permutations of length n with exceedance pi is d which have a and g as a cyclic factor. And the conjecture is BND1J plus BNDJ1 equals to twice PND1J. Tong Zhao and his postgraduate Yue Sun and I completed a proof in 2022 used generating functions. So both spurious conjecture and refined conjecture are proved by generating functions. We want a combinatorial proof using combinatorial bijections. The bijection is in the second part, a decomposition of Ballot permutations. Professor Zhicong Lin, David Guoliang Wang, and Tong Zhao presented an algorithm that decomposes Ballot permutations into all cycles. Let pi in Sn and k from 3 to n. The value k is called the peak of pi if k is greater than its left and right neighbors in pi. And k is called a cyclic peak of pi if k is greater than its cyclic neighbors. For example, in this permutation pi, 9, 6, 7 are peaks, and we decompose pi into 3 cycles, and the cyclic peak is 8, 6, 9. 9 is greater than its left cyclic neighbor 3, and is greater than its right cyclic neighbors 2. The cycles 2 is after the 9. And their main result, there exists a bijection C from Bn to On that transforms the pair death peak to exceedance C peak. And the proof is quite complicated, so I just talk about its sketch. Let A be a set of positive integers such that the element of it is increasing. And box permutations on A are separated properly into several increasing segments by boxes, denoted by BPA, the set of all box permutations on A. For example, if A is a set consists of 1, 2, 3, and BPA has 7 elements, the box may not appear in BPA. But if the box is appeared, its neighbors are also increasing segments. A collection of cycles is called a cyclic box permutations on A. If each cycle is either an odd box cycles or reverse odd box cycles on A, and each element of A appears once in exactly one of the cycles, the set of all cyclic permutations on A is denoted by CBPA. For example, A is consist of 1, 2, 3, and CBPA also have 7 elements. Each cycle have odd numbers. Box takes a place. The bijection is also a sub-bijection from BPA to CBPA. The first step is decompose a Ballot permutation into subword. It replaces each maximal Dick permutations by box. For example, here is a Ballot permutations of length 20, and its maximal Dick permutation replaced by box. The Dick permutation is a special Ballot permutations, which its descents and ascents are the same. For example, here is a Dick permutations for its ascent and descent number is both 3, and here is also. They are all replaced by box. we get a box permutations. Step 2, they constructed a box neighbor set preserving bijection C from BPA to CBPA. So the box permutation are changed into a cyclic box permutations. And the last step, they replace each box by the original maximal dig permutations. And we get an odd order permutations. So after 3 steps, we established a bijection from Bn and On. This bijection can extend it. The Ballot permutations are extended to well-labeled positive paths. Well-labeled positive path is Ballot path at horizon step. And D permutations at horizon step extend to Motzkin permutations. And odd-ordered permutations extend to odd-ordered cluster permutations. It means if more than 2 numbers in a cluster, it only take 1 place. So 1, 2 cluster, 3, 4 is an odd-ordered circle. And the last section is the pattern avoidance on Ballot permutations and words. A permutation pi is said to avoid the pattern tau if there does not exist. Its subword is ordered isomorphism to tau. For set P of permutations denoted by P from tau 1 to tau m, the set of the permutations in P avoiding the patterns tau 1 to tau m. 2 sets of patterns are said to be Wilf equivalent over P if the cardinality of P avoids the first set and P avoids the second set are the same. The bincular pattern of length m is a permutation in Sm, of which consecutive letters may be underlined. For instance, the permutations contain the bincular pattern 1, 2, 3 corresponding the subsequence 4, 5, 6 and 4, 5, 6 are adjacent. Also, they contain the bincular pattern 1, 2 adjacent and 3 corresponding the sequence of 1, 4, 6. 1 and 4 are adjacent and 4 and 6 are not. Zhi Conglin, David Guoliangwang, and Tong Yuanzhao enumerate the Ballot permutations avoid a single pattern of length 3 and establish a connection between Ballot permutations avoiding the pattern 2, 1, 3 and guess works. The result we are listed here. And Tong Yuanzhao and his postgraduate Xiaoqing Li and Yue Sun enumerate the Ballot permutations avoiding bincular patterns 3, 2, 1 and other patterns of length 3. So, the Ballot permutations are avoiding 2 patterns of length 3. One is always bincular patterns 3, 2, 1. And I and my postgraduate Jiahui Wang and Yuheng Yang enumerate the Ballot permutations avoiding the bincular patterns 1, 2, 3 and other bincular patterns of length 3. There are 15 vincular patterns of length 3 with the vincular patterns 2, 1, 3. Here are their formulas, and some of them are Catalan number, or the number of increasing 0, 1, 2 trees on n vertex. For any vector m denoted by Sm, the set of multi-permutations on the motif side, and the Ballot multiple permutations is also called Ballot words. And the Ballot words must hold the inequalities here. For each mi equals 2, it's also a Ballot word use the number 1 twice, 2 twice, and n twice. Some results have been obtained by I and my postgraduate Ziyi Yang. Some of the results are Ballot words consist of 1 from 1 to n twice, avoiding 2 patterns of length 3. Some of the results are avoid 3 patterns of length 3, at least here. All formulas hold for n is greater than 3. Here's the reference. Thank you for your attention. Here's a photo of Hebei Normal University. Welcome to visit.